So one of the word problems you will encounter with differentiation topic is likely to be about related rates. Okay, here we have a question that was in the practice mock exams. Now, at the top you're given some dimensions about a triangular prism shaped swimming pool, and as you keep reading it says the hose is filling up the pool at a constant rate of 125 litres per minute. And what rate is the area of the surface of the water increasing when the height of the water reaches 1.2 meters? So the key is you want to find out what is given and what are you finding. So we knew it was dV over dt because it's the water being filled up with respect to time. Rate is always with respect to time. So I've got dV over dt is 125 litres per minute. And they asked you about how the surface area is changing when height is 1.2 meters. So from that we get this part here. Okay, now the next part is to link what's given and what you're finding using the chain rule. So here we want dA over dt, and dV over dt is given. So I know I need the dA at the top. The question is, what am I going to have? Now, I do want dA, and I do want dt, but what I don't want is dV, so I know that I need dV down the bottom here. Okay, now I know it's dV at the bottom here, not below dA, because we don't have a formula linking volume and area together in this case. So this is what we have. What we can do is get volume in terms of height. So that's going to be our rule. Now this is the diagram that I've redrawn here for you. So that bit there is the length, this one is the length, and that's the height, and that's changing as the water is filling. Now, using similar triangles, we can say that L over 28 is equal to H over 1.8, and from that we can rewrite L to be in terms of H, because volume is area of cross-section times the width. So I've got here the formula for volume, half times length times height, which is the area of this triangle here, times by the thickness of the swimming pool, or the width of the swimming pool. Okay, now that we have the formula for the volume, we simplify it and we can find dV over dH by differentiating. So we've got dV over dH. Now what we do need is also dA over dH. So this is the top surface of the water, that's L, and that's 5, so it's 5L, but we want it in terms of H, so again replace L to be in terms of H, and here we have our formula for the surface area of the water, and when you differentiate you get dA over dH. Now, putting it all together, okay, they've given us the dV over dt in terms of litres. We want it to be in meters cubed, so we've converted that, and just using the formula that we've set up before, that's our dA over dH. This is dH over dV, and that's dV over dt. And simplify that, this is what you get. Substitute that in, and here we have our final answer. So this is really the crux of it all. So making sure you know what you're given, what you're finding, link them together, and the rest of it is just mechanics. More practice will hopefully make it easier for you.